Hi guys, in this video I am going to discuss about how to implement my FrameCapture plugin in your own projects. I am going to first create a new blueprint project. Once the project is opened, we first need to open the plugin window and enable our FrameCapture plugin. We might need to restart the editor after enabling the plugin. Once we enable the FrameCapture plugin, we need to go to Project Settings and, in the Game Viewport Client class option, replace the default Viewport Client with FrameCapture Viewport Client. We must restart the editor once again after making this change, or the engine might not get updated with the new Viewport Client class. Alright. I am in the third-person game mode now, so I am going to open up the third-person character blueprint. I want to take a snapshot when the I key is pressed. Now, before we can take a snapshot, we need to spawn actor from FrameCapture class. We save the spawned actor in a variable. We don't want to spawn an instance of FrameCapture class every time we want to take a snapshot, so let us check for validity here, and spawn only if the actor variable is not valid. Once we have a valid FrameCapture actor instance spawned in the level, we take its reference and call the function Initialize Screen Capture to take snapshot of the current frame. We can either choose custom resolution or take the snapshot at viewport resolution. If we choose use viewport resolution, we don't have to specify custom resolution separately. To save the image to hard drive, we must check the Save to Disk option. If you want the user to choose the file name manually, you can call the Get Save File dialog option. To save as image files, you must specify the file types as image files, in the specified format. Alright, so now let us test it out. Okay, so pressing the I key brought up the Save File dialog, where we can choose the path and the file name we want to save our snapshot at, and then press OK. Whenever a new screen capture is requested with the Save to Disk option, the event on Screenshot Saved is triggered when the request is successfully processed, and this event can be used to perform tasks like adding notifications when the screenshot is successfully saved. Next we will look into how to take a snapshot and load as texture that we can display in our UMG widget. For that, I have created a UMG with an image that we want to load with our snapshot. In our widget blueprint, I have added a custom event called setBrush with texture as input parameter, which is used to load our image. Now we will move over to our player character blueprint, where I want to add this widget in viewport. Let us add this in begin play event. So while pressing I key, I want to load snapshot of the current frame as texture, instead of saving the file in the hard disk. For that we have to call the function Initialize Screen Capture again, but this time unchecking the Save to Disk option. Since we are not saving in the hard disk, we don't need to specify any file name here. We also need to bind the on-screen captured event for our spawned FrameCapture actor instance. This event is triggered when a snapshot is requested without Save to Disk option. In the on-screen captured event, we receive the texture output created when the snapshot is requested. We can pass this texture in our UMG containing the image to display the texture in viewport. Now we are going to test out the result by pressing the I key. As you can see here, the snapshot captured on pressing the I key is being converted into texture and displayed in the viewport. To capture the entire window as viewed, for example, to capture the viewport along with widgets and other UI as visible on screen, we need to call the function takeSnapshot with UI. This executes in the game thread and doesn't need the FrameCapture actor as reference, nor does it need any custom bound events. I want to call this function when U key is pressed. So I am connecting this with the U key event. Now we need to specify the file name, so let us again use the Save File dialog option to choose a file name and path to save the snapshot. Alright, so let us test this out in the level. First we press the I key to display the current snapshot as texture in viewport. Now pressing the U key brings up the Save File dialog, where we choose the save location. Here we can see that our snapshot has been saved with UI. Now that we have looked into how to take snapshots, we can move over to the video recording feature. I want to record video when the V key is pressed. So before beginning the video recording, we again need the FrameCapture actor reference. So here also I want to spawn the FrameCapture actor and save its reference, like we did previously. Once we have reference to our FrameCapture actor instance that we have already spawned, we need to call the function Initialize Recorder, which begins the recording process, and your game will now start getting recorded. In this function, we need to enter the target FPS of the recording, the file path, and if we want the UI to be visible as well, via the Show UI option. We can again use the Save File dialog option to choose the file path where the video needs to be saved. But here the file types should be video files, preferably of AVI or MP4 formats. I have created another widget to add notifications when a video is being recorded. I have added two events in this widget, one for notifying the widget that the video recording is started, another to notify that the video is currently paused or resumed. Now I want to add this widget in our viewport when the video recorder is initialized. Once the widget is added, we can notify the widget that recording has been started, to display appropriate message on screen. Now, I want to use the P key to pause or resume the recording, once it has been started. To pause or resume current recording, we can take the reference of our FrameCapture actor, and call the function Toggle Pause Recorder. Now, we want to know if the recording is currently in progress. For that I have added another variable when the recorder is initialized. When we pause or resume current recording, we want to notify our widget accordingly, so that appropriate message can be displayed on screen. The FrameCapture actor has a variable called isPaused that can be used to check if the current recording is paused. I also want to stop the current recording when the V key is pressed again. To do that, we need to check if the game is currently being recorded, and if yes, then we would instead get the FrameCapture actor reference and call the Stop Recorder function. Here we can get our widget reference and remove it from viewport. Alright, let us now test out the video recorder functionality in play mode. Pressing the V key brings the Save File dialog where we choose our file path to save the video output as. Pressing P anytime would pause and resume the recorder, and we can see the appropriate message through our notification widget. So we can see the video has been successfully recorded at the desired frame rate per second. To display the UI in your video output, you just need to enable Show UI option in the function Initialize Recorder. Now I will talk about updating the depth of field for the given camera component, to give your snapshot a nice professional and cinematic touch. The function, update_DOF bucket, takes the camera component and depth of field bokeh settings to update the corresponding values for the given camera component, setting the depth of field type as bucket. Similarly, the functions update DOF Gaussian and update DOF circular will take the camera and the depth of field settings and update the depth of field values for the given camera, enabling Gaussian and circular as depth of field type, respectively. I have designed a user interface containing some changeable values which corresponds to the depth of field settings, which we can apply to our camera in real time by calling the appropriate functions as mentioned before. If you look into the event graph of this widget, you can see that I have created few event dispatchers which I am calling when the depth of field settings are updated from the user interface. These event dispatchers are bound to the player character class, where I am updating the respective depth of field settings for the camera. So in the play mode, we can see how updating the respective parameters from the user interface would affect the depth of field settings of our camera. I hope you liked the tutorial. For direct support, join me in Discord.